My name is Balboni and I am a PhD student in Science and Material Engineering. The title of my work is Influence of Weathering, the electrochemical and morphological characteristics of cerium dioxide and cerium dioxide with vanadium pentoxide sol gel thin films. Most electricity costs in Brazil are related to the acclimatization and artificial lighting of commercial and residential buildings. A promising alternative is the use of smart windows. So these devices are based on a property called electrochromism. When an electrical potential is applied to an electrochemical material, an ion insertion occurs in its layers, which leads to a change in its optical properties and in a color change of this material. So when this electrical potential is ceased, the material tends to return to its initial coloration. So the device consists of several layers. At the ends, there are two glass layers. There are two conductor substrates. There is an electrochemical film that is separated by an electrolyte from another film, which works as a counter-electrode. So initially, the device allows the passage of the heat and light. When the potential is applied, the ions and electrons migrate to the electrochemical film, which changes its coloring. The material then stops transmitting and then starts to reflect. When the potential is ceased, the ions and electrons migrate to their layers, the material returns to its initial color, and from the reflectance we return to transmittance. So the cerium dioxide has good transparency during the intercalation, and the vanadium pentoxide has good charge storage. By combining these two materials, we can work with both properties. So for the preparation of the salt of cerium dioxide, cerium chloride heptahydrate, citric acid, and ethyl alcohol was stirred for 30 minutes. For the sol of the doped film, vanadium isopropoxide were added to the first sol and stirred for 10 minutes. An accelerated weathering chamber were used to simulate the exposure of the films to the environment. So by the chronocoulometry, it was possible to study the charge density. The films presented some variations during the process, but the doped film presented better results at all analyses. The cyclic voltammetry presents a higher area for the doped film, which is the one on the right. That means that there are more ways for the ion movements. By the impedance analysis, the Nyquist plot presented a 45 degrees angulation, which means that the charge transport occurs through diffusion. Through SEM, it was possible to observe that for all films, pre- and post-weathering, there are some cracks and irregularities on their surface. So we can conclude the material containing vanadium pentoxide presented better results in all tested scenarios. It confirms the efficiency of the doping. It is also possible to conclude that even after 2.5 years of exposure to the weathering, the material continues performing well and presenting promising electrochemical properties, which is important for the proposed application of this type of material.